Hi all, welcome to another video of the subject Electrical Machine Design based on the KTU syllabus, and we are on module 3, and today we are going to discuss about the separation of D and L for the DC machines. That is, D and L means the diameter of the core and L is the length of the core. So how can we separate the D and L from the output equation, that is Q is, that is in the case of a DC machine we know that it is PA is equal to C0 D square L N. So in the question itself we will be given the value of PA, and we can find the value of C0 and we can find the value of N. So D square L, we will get a value of D square L from this equation, and for separating the value of D and L from the D square L we have to use some points here. So in the DC machine the separation of D and L mainly depends on the pole proportions, moment of inertia, then the peripheral speed and voltage between adjacent commutator segments. So the first one is the pole proportions. In most of the questions we may be using the pole proportions, so it is having the highest priority. So in most cases we will be using a square pole criterion, square pole sections. That is, for a square pole type structure the length of mean turn of field winding is minimum. So here you can see a figure of the pole sections we are using. So square pole means here the length of the core L will be equal to the pole arc B. Here this is the pole arc and this is the length of the core. So L will be equal to pole arc B. So we know that when L is equal to B and there is a ratio of psi, that is psi means the ratio of pole arc to pole pitch, that is I is equal to B by tau, B by tau. So in the case of a square pole this B will be equal to L. So in most cases we will be saying it is L by tau. Okay, the value is L by tau. So we will be choosing the L by tau value for a square pole section as 0.7, but the range is between this 0.7 to 0.9, but we for doing the problems we will be using the 0.9. And here the value of the tau is pi d by p, where d is the diameter of the core and p is the number of poles. So the first one is the pole proportions, and next one is the peripheral speed. So normally it is the limiting factor to the value of the diameter. Okay, and we know that the equation for peripheral speed we are using is Va is equal to pi d ns, pi dn. Okay, so here the value of Va, the Va shouldn't exceed 30 meter per second. It may be given in the question itself, and we can find the value of n, and from that we can find the value of d. Okay, so the second method is by using the peripheral speed, and the third one is the moment of inertia. That is, for machines used in control systems a small moment of inertia is desirable. Okay, so for low moment of inertia the diameter should be made as small as possible, and conversely a high inertia machine may be required for impact load applications, and such machines are designed with a large diameter. Okay, so that's the case of moment of inertia. So based on that we can design the diameter of the rotor. Okay, if the moment of inertia is low the diameter will be low, and for high moment of inertia the diameter is higher, and that is the third point. And next one is the voltage between the adjacent commutator segments. Okay, so here the maximum core length is fixed by the maximum voltage that can be allowed between the adjacent segments. So the equation for maximum voltage between the adjacent commutator segments is ECM is equal to BGM LVA into TC, where BGM is the maximum air gap flux density under load conditions and TC is the turns per coil. Okay, and the limiting values for BGM is 1.2 Weber per meter square, and VA is, we know that it is 30 meter per second peripheral speed, and the maximum voltage between the adjacent commutator segment is 30 volt. So by using that values, and by assuming the TC, okay, TC as 1, that is turns per coil as 1, by substituting these values in this equation, we will obtain the value of L as 0.4 meter. Okay, so the turns per coil may be changed, so based on that the value of L also may be changed. Okay, so this is only an indication of limiting value of core length, but it must be clear that large DC machines should have large diameter rather than large core lengths. Okay, so in large machines, most probably in large machines, it will have large diameter. Okay, so these are the main points while designing the value of L and D. Okay, for separating the value of L and D from D square L, the 4 points, that is pole proportions, then peripheral speed, then moment of inertia, and voltage between adjacent commutator segments. So I hope all of you understand these points well. So thank you.